Good day, viewers. Welcome once again to Isaac Mathematics Clinic. Today, we want to solve some other questions on logarithm. If you take a look at the board, there are some questions there that look scary and time consuming. But actually, they are not time consuming. So let's get it started. Question number 1 states, find the value of r. Here we have logarithms of the same basis. According to that law of logarithm, to add logarithm of the same basis, all we need to do is to multiply the numbers. So this becomes logarithm in base 10 of r times r raised to power 2 times r raised to power 4 times r raised to power 8 times r raised to power 16 times r raised to power 32 is equal to 63. Then this is now equal to logarithm in base 10 of. Now these numbers are indices. And according to law of indices, when we are multiplying indices of the same base, we are going to add their powers. So the power of r here is 1. Then this multiplication becomes r raised to power 1 plus 2 plus 4 plus 8 plus 16 plus 32. And the whole expression is equal to 63. And this is now equal to logarithm in base 10 of 1 plus 2, 3, 3 plus 4, 7, 7 plus 8, 15, 15 plus 6, 31, 31 plus 32, that is 63. Logarithm in base 10 of r raised to power 63 then is equal to 63. Now, what does this expression here mean? The expression at the left hand side. It means what is the power to which 10 must be raised so as to get r raised to power 63. And now we have already known the power to which this 10 must be raised. That is the number at the right hand side here. So that means 10 must be raised to power of 63 so as to get r raised to power 63. Now if you look at these powers, they are the same. Then definitely their bases are also the same. So from here, r is equal to 10. It is as simple as this. Now, question number 2. Question number 2. Logarithm of root 27 in base x plus logarithm of root 8 in base x minus logarithm of root 125 in base x all over minus open bracket logarithm of 5 in base x minus logarithm of 6 in base x. Now, we have two logarithms of the same base here to add. So according to the law of logarithm, we are going to add the numbers. So up here we have logarithm in base x of root 27 times root 8. Then minus logarithm in base x of root 125. All over. So down here we need to open the brackets. So minus times plus will give us minus. This is minus logarithm of 5 in base x. Then minus times minus is equal to plus. So plus logarithm of 6 in base x. up here again, we want to apply that second law that says that whenever we want to subtract two logarithm of the same base, then we need to divide the numbers. And this is now equal to logarithm in base x of root 27 times root 8 all over root 125. Then all over, here we can rewrite this as logarithm of 6 in base x minus logarithm of 5 in base x. So this is still the same thing as what we have here. Just like when we have minus 2 plus 3, we can say it is 3 minus 2. Now let's proceed. Then this is equal to logarithm in base x of, now if you take a look at this, according to the rule that guide the operation of sort, we can rewrite this as square root of 27 times 8 over 125. So all of them are enclosed in the same rule, according to that rule that guides the principle of sum. So all over logarithm of 6 in base x minus logarithm of 5 in base x. Then this is equal to logarithm in base x of roots. Now if you multiply 27 by 8, we are going to get 27 times 8. Let's do that. 7 times 8, 56. 6 remainder 5. 8 times 2, 16 plus 5, 21. So we are going to get 216 all over 125. Then all over logarithm of 6 in base x minus logarithm of 5 in base x. Then we can rewrite this as logarithm in base x of, now square root of a number simply means the number is raised to power 1 over 2. Cube root of a number means the number is raised to power 1 over 3. So now, square root of 216 over 125 now is 216 over 125 raised to power 1 over 2. Then all over. Now let's quickly apply one of the law of logarithm to simplify this. This is equal to logarithm of 6 divided by 5 in base x. Logarithm of 6 divided by 5 in base x. Now, according to this, in mathematics, you want to simplify this. You should be able to think of the way you can divide either numerator by denominator or denominator by the numerator. There is a pattern we have here, 6 over 5. So you can now strategize. How can I rewrite this 216 over 125 in terms of 6 over 5? Then how do we do that? We can just say 216 over 125 is the same thing as 6 over 5 raised to power 3. Now 6 over 5 raised to power 3 means 6 over 5 times 6 over 5 times 6 over 5. So 6 times 6 times 6, that is 216. Then 5 times 5 times 5, that is equal to 125. So instead of 216 over 125 now, we are writing 6 over 5 raised to power 3. Then this becomes logarithm in base x of 6 over 5 raised to power 3 then raised to power 1 over 2 originally here. Then all over logarithm in x of 6 over 5. Then this is the same thing as logarithm in base x of 6 over 5 raised to power 3 over 2. According to one of the laws of indices, whenever we have two powers, we need to multiply the two powers. So 3 times 1 over 2 will give us 3 over 2. Then all over logarithm in base x of 6 over 5. Then, according to one of our laws of logarithm, this 3 over 2 here will be transferred to the left hand side so as to become the coefficient. Then this is equal to 3 over 2 logarithm of 6 over 5 in base x all over logarithm of 6 over 5 in base x. Then if you take a look at this, logarithm of 6 over 5 in base x is up here, and we also have it down here. So the two of them can easily cancel each other. So this cancels this. Then we are left with 3 all over 2, and that is the answer. So here we have used virtually all the laws of logarithm. Thank you very much for your time. Please don't forget to follow my Facebook page, subscribe to my YouTube channel, comment, like, and share. Thank you very much.